Greetings to you all. This video is an introduction to chapter 15 of the Cambridge AS and A-level chemistry syllabus 2026. And this topic covers a group of organic compounds known as haloalkanes, and these are also known as haloalkanes. So these two words mean one and the same thing. They are both names of this group of organic compounds. Now, as the names suggest, these are alkane molecules or are alkanes that contain halogen atoms. In other words, these compounds are identified by the presence of a carbon halogen bond in their molecules. The carbon halogen bond in their molecules. And this carbon to halogen bond is the functional group of this group of organic compounds known as haloalkanes, or they are also known as halogenoalkanes. First on the list for us to talk about is the formation reactions of these compounds. The reactions that are used to form the haloalkanes. Now, there are basically only three main types of reactions that are used to make haloalkanes. And these are the ones that are represented on the mind map diagram that is shown on the screen right now. The first type of reactions that can be used to make haloalkanes are known as alcohol substitution reactions. Alcohol substitution reactions. These are reactions in which an alcohol is represented by that displayed formula there. In these alcohol substitution reactions, the OH group, known as the hydroxyl group, which is the functional group of alcohols, the OH group, this one, is replaced or substituted by a halogen atom to then give a haloalkane. So these are the different alcohol substitution reactions which will give a halogenoalkane or haloalkanes. Now, as shown on each of the reactions, there's an alcohol reacting with another substance. Like in the first place, an alcohol can be reacted with phosphorus 3 chloride. And this will give a chloroalkane because the halogen atom present in the reagent are chlorine atoms. So they'll give chloroalkanes. But that reaction to occur, it requires a special condition, and that condition is heat. The other way by which we can form chloroalkanes is when we react an alcohol with phosphorus 5 chloride. This, unlike the first one, does not have any special conditions, and that will also give rise to chloroalkanes. Just mix the phosphorus 5 chloride and the alcohol, then a reaction will take place that will give a halo or a chloroalkane. And then the other way we can form the chloroalkanes is by reacting the alcohol with the sulfur dichloride oxide. The sulfur dichloride oxide, which will also give a chloroalkane. This is considered the most ideal way to make a chloroalkane. How and why? Because the other products of these reactions are both gases. So as soon as they are formed, they evaporate and leave the reaction mixture, leaving behind only the chloroalkane. So this does not require any purification of the products. So that is the reason why it is considered the most ideal way to produce a chloroalkane. And then the last alcohol substitution reaction that is used to make haloalkanes is where we react an alcohol with a hydrogen halide. However, the hydrogen halide will be made in situ. What this means is that instead of mixing the hydrogen halide directly with the alcohol, the hydrogen halide is formed through a reaction that takes place in the reaction mixture. So, say for example, we want to form chloroalkane, we take potassium chloride, which contains the halogen atom that is needed to substitute the OH. So the potassium chloride is then reacted with sulfuric acid, and this will give hydrogen chloride. This will give hydrogen chloride. And so when the reaction takes place, we mix the alcohol, the potassium chloride, and the concentrated sulfuric acid. Then we heat that reaction mixture. It is during the reaction when hydrogen chloride is then formed. It's during the reaction when the reaction is taking place. That's when the hydrogen chloride needed to react with the alcohol is formed during the reaction. So that we say the reagent has been formed in situ. And then the second type of reaction that can be used to make haloalkanes is known as the alkane free radical substitution. We discussed this when we looked at the reactions of alkanes, where we said that the substitution reaction requires UV light. That's a condition that is needed for the reaction to take place. And then we form a haloalkane from the reaction between a halogen and an alkane. And the last, we have also made this before when we discussed addition reactions of alkenes. And this specific example of an addition reaction of alkene is called halogenation. This is where we add halogen atoms to an alkene. We can do this either by reacting the alkene and the hydrogen halide, or we can react an alkene with the halogen itself, and both will give rise to haloalkanes. So this mind map diagram shows the different reactions that are used to make haloalkanes, which are basically number 1, number 2, and number 3. So those are the reactions that are used to form haloalkanes. Thank you.